Hi, CP Algebra 1. This is going to be for the review packet we gave you. This is for the unit on sequences. So there'll be a couple of videos that I'll go through and do these. So it says in a geometric sequence, how do you find the next term? Okay, so we add the common difference. Okay, do we subtract the common difference? Do we multiply by the common difference? Do we divide by the common ratio and divide by the common ratio? Well, remember geometric, you add the common difference. Sometimes you might be adding negative numbers together, but that's fine. And then it says, number 2, which equation represents the recursive form of an arithmetic sequence? So arithmetic sequence, remember, has a common difference that you're adding. Well, there's a ratio. You don't multiply doing those. This is a ratio as well, so it has to be answer B. Okay, so I'm kind of looking for the plus D at the end in that situation. In the explicit form of a geometric sequence, you have A times the rate raised to the n minus 1, or the ratio. What does A represent? Well, the common ratio is R. The common difference we don't do with geometric sequences in series. The first term of the sequence, maybe, let's see, the last one, the number of terms. Nope, it's got to be the very first term. It's got to be the first term of the sequence or series. So this is the very first term. Okay. Number 4, the sequence has these terms, 3, 7, 11, 15, and 19. What type of sequence is it? Well, we have to ask. Are we multiplying to get to the next number? Are we dividing? Or are we just adding 4 to each time? I think we're adding 4 to each time. What do you think? If I do that, it's got to be arithmetic. And it's the same each one. If it was like 4, 5, 6, then it would have been a neither. But this one's arithmetic because I'm adding the same common difference each time. What is the common ratio of 2, 6, 18, 54, 62? So remember, geometric, you're multiplying. So what am I multiplying each time to get to a different number? Well, what do I have to multiply times 2 to get 6? That'd be 3. What do I have to multiply 6 times to get 18? What do I have to multiply 18 by to get 54? Well, if you use a calculator, 18 times 3 is going to give you 54. And then 54 times 3 is 162. So you're multiplying. So our common ratio is 3. We're multiplying each term by 3. In the arithmetic sequence, our first term, f at 1, is equal to 5, and a common difference is 3. What is f at 4? Okay, so we have to think about this. We have f at 1 that's given to us, and then we have a common difference of 3. Okay, so if you remember from the posters in the room, arithmetic sequences in series, you have f at n equals what's the rest of it? Find the poster in the room. So we're looking at the explicit. So we're going to look at the first term. We have the common difference there. So someplace we're going to have to put an n. Or it looks like we're going to add 3. Okay, so we're going to call that n, f at n plus 3. So if I plugged 1 back into this, you can double check your work. This is 5 times 1 plus 3. Is that the answer? I mean, that gives me 8, and we had 5 here. So what did we do wrong? Well, remember, this is the first term. Remember, we want the 0 term. If this is not the 0 term, what do we plug in for n? I know it was a while ago, but what do we have to plug in? Some of you might remember. I have to go n minus 1 right here, and then plus 3. Okay, so what that's going to do is that would allow me to verify my answer. If I did f at 1, meaning I'm going to plug 1 in, I'm going to get 5 minus 1 plus 3, which is 5 times 0 plus 3. Oh, that's still not going to work. What else do we have to do? Anybody remember? So another way of thinking about this is kind of like the slope. This is a point 1 comma 5. So sometimes when you get stuck on this, you might look at it and say, well, my equation, if I use my point slope, is this. Remember that? So then I'm going to call this x1 and y1. I have my slope. So if I plug those in, I get m equals 3. And then I'm going to get x minus 1, plugging that in. Remember the sign switches, plus 5. So that's our equation there. So if we were to plug 1 in here, 1 minus 1 is 0 times 3. Oh, that's what I did. Remember that? I should have had the 3 here and the 5 there. Silly me, I made the mistake. Okay, so that means that our equation is 5n equals 3n plus 5, which if I were to do this, it would allow me to get the 0 term. So if I do that, what would happen if I multiplied this out? 3x minus 3 plus 5, which is 3x plus 5, or 3x plus 2, excuse me. And that would be for if I had the 0 term, if I want to plug it in. If I plug 0 in, that would work. Now, if I want f at 4, I'm going to plug 4 in right here. So I'm going to get 12, because 3 times 4 is 12, plus 2, which is going to give me an answer of 14. Okay, so I had a kind of a roundabout way. I had to use a little thinking for it. So if you work through it, I bet you can get it. Okay, it says, which sequence is neither arithmetic or geometric? Well, this is going times 2 each time, right? So that's geometric. First one's geometric, but we want neither. And this one looks like I'm adding 4 each time. So plus 4, plus 4, plus 4, plus 4. So that's arithmetic. What about this one? This is plus 3, plus 5, plus 7, plus 9. Okay, wait. Can we multiply by something? Nope. Hang on, let's just verify. So this one I'm going to put a question mark. So I'm subtracting 3 each time here, and that's a common difference. That works. So it's definitely got to be C. Those happen to be perfect squares, and they are not arithmetic or geometric in this case. We want to write the explicit function of this, so let's take a look. They say it's arithmetic, so it looks like I'm adding 12 each time. Okay, so if we do the arithmetic, it's f at n. Common difference is 12 times n. What's my very first term? So we don't know if, is this a at 0, a at 1? In that case, that would have to be a 3, which I would agree with. That's going to work nicely. But look, our answer is not there. So what did we do wrong? Well, if we recognized that if I had a 0 term, that's fine. But if I went to the first term, realize I'm going to have f at n minus 1, basically. Okay, remember that? If I do it with the first term, not the 0 term, the first term, does this look like any of the equations? Yeah, it's letter C. Okay. Number 9, in the geometric sequence, the first term is 10. So A1 equals 10. The common ratio is 1/5. All right, so we are doing geometric. Okay, so this is going to be f at n equals, the first term was 10 times the common ratio of 1/5 raised to the n. If they want the third term, I'm going to plug a 3 in here. So I'm going to get 10 and then 1/5 raised to the third power. So on a calculator, 1 times 1 times 1 is 1. 5 times 5 times 5 is 125. So I wind up with 10 over 125, and I bet you can reduce that. 5 goes into there twice. 5 goes into 125. 25 times, so 2 over 25 has to be answer C. Which of these equations represents a geometric sequence? Geometric sequence, remember, doesn't have a common ratio, so it's not that one, it's not that one, it's not that one, so it has to be letter C. Okay, so you might want to jot some things down for your Unit 1. Perhaps you could ask your teacher to re-clarify something. Have a nice day, everybody.